This is Tim Hegarty with the virtual training company C++ Fundamentals. We are now going to take a little deeper look at the fundamental of class member access, and this gives us the term encapsulation. Encapsulation allows us to have functions or methods, they're called in classes, and data members of the classes totally enclosed within the class unless we specify otherwise. Whenever we create a brand new class and don't say otherwise, the members, methods, data, everything that's in there is private. That's by default. The class members can then only be used by the class member functions. The methods that are built into the class can only get to that data that's part of inside the class, or classes specified as friends, and we'll take a look at that in a little while in a different video. We can specify public access. Public access means that any other function can get to or call those class members and methods. It's totally open. Protected is kind of a combination. Protected access says that the class members can be used by the member functions of the same class and by any derived class member functions. So if we have a higher level class of car, let's say just a car, and then we derive a class below that of Ford, then the derived class could make use of things that are in the car class that are above it, that it has been derived from, but nobody else could get to it. So you kind of have a family tree going on here of classes when you have derived classes like that. Here, for example, is a simple my class being created. All of these members, X, Y, and Z, are private because we have not said otherwise. So only, and we don't have any here, we haven't defined any methods, but only methods of my class would be able to work with X, Y, and Z and store things in them. Gives a very tight black box, or encapsulates the data within the class. Now here we have used the public keyword in this class, and X is still private because it comes before the public access specifier. Y and Z, however, are now public, so any other function, anything else that wanted to get to myClass.y could get there and work with it. And then finally, here's the protected. We have int X is still private, int Y is now public, and we have the protected is Z. We can work with functions within my class, methods within my class can work with Z, and anything that is derived from my class can work with Z, but nothing else can get to it. So it's encapsulated along the lines of the family tree. And this is class member access, which implements the fundamental of data encapsulation within object-oriented programming. This is Tim Hegarty with the VTC C++ Fundamentals. Let's talk about some friends. Friends are other functions that are allowed to operate on our class that we're defining, on our class's private and protected members. Because remember, we have public, private, and protected. And private and protected are not visible to the rest of the world in general, but public are. Now, we can, though, in a class say that this is a friend. So let them do what they need to do with private and protected members. A friend may be a method in another class, or it can just be a simple function out at global scope. Either way is fine. The friendship is declared in the class that's giving the friendship away, that is defining the friend, because that way it maintains control over who is a friend and who isn't. Let's take a look at a piece of code here. And here we have a class called point, and within this class there's a public area. We're going to skip over the friend here for a second. There's a public point which has a value, and then there's a method here that's a print private, and it's going to print out the value of this m sub I, or m underscore I, which is a little integer down here that's private. So nobody can get to that because it is private until we make a friend function up here. So here's a friend declaration. No return. This function called change private, it'll be given a point reference. This change private is allowed to do whatever it wants with the private members down here. Now here's the actual definition of change private. And when we're defining it in here, definition and declaration, it's an inline. And all we're going to do is increment the value. We'll just bump it up by 1, and that's that. So we come straight to the location, add 1 to it. Down here in main, here we make a new point. This is an S point. We say that sPoint.printPrivate. So we're going to find out what's in there. We're going to call change private, which we really should not be able to do. Only this friend declaration up here allows us to change that. And then we'll print private again. All right, pretty straightforward. Do a quick Control F5, and there's 0 and then 1. Not very impressive, but it does illustrate our point here that this, so to speak, this class point has allowed or created a friend which is able to get to this private member and do something with it. Now that breaks down some of our encapsulation concept, so you have to be careful who you define a friend and just what that friend is allowed to do. So that is the concept of defining a friend method in our encapsulation topics here.